Hey guys, welcome to the video for parallel lines. We are in Unit 4. Our essential question is, how can you tell if two linear equations are parallel? So prior to this, we learned in Unit 3 the three different types of forms of a line. We first learned point-slope form, then slope-intercept form, and then finally our standard form. Now you will need to know those three forms in order to move on through Unit 4, so it is important that you are having a strong foundation in that before you actually encounter Unit 4's material. But I have a graph in the corner, and I know you don't in your notes, and hopefully you are going to take notes. But I have a graph over here just because I want to kind of demonstrate something. So I want to first ask you, what form are these equations in? Well, if you aren't able to recognize, hopefully you can see that it looks like y equals mx plus b. Now remember, this is also known as slope-intercept form. Intercept. This is known as slope-intercept form. And we learned in Unit 3 it is called slope-intercept form because it provides us a slope and the y-intercept. So if it's in slope-intercept form, then I would already be able to identify the slope and the y-intercept because it's in slope-intercept form. Y is by itself. I have y equals mx plus b. So our slope for this red equation is going to be positive 2. Remember, your slope is attached to the x in slope-intercept form. And when you're graphing, you always want to write your slope as a fraction. So I'm going to have positive 2 over 1. And then my y-intercept is going to be the b value, which is going to be 0, negative 1. So I'm going to go ahead and start graphing that red equation. So the y-intercept is going to be at negative 1, and remember the y-intercept is on the y-axis. And then I'm going to use my slope of positive 2 over 1, which means I'm going to rise up 2 and go to the right 1. And I'm going to go ahead and do that for as many points as possible. So I'm also going to go in the opposite direction as well. Okay, so here's my line so far, and I'm going to go ahead and draw a line through those and put my arrows there. So this is the graph of the red line. Okay, and then we're going to go ahead and graph the green one as well. Now this one's also in slope-intercept form, which means I can identify the slope and the y-intercept without having to do any work. So my slope here for the green one is positive 2, but again, you want to write that as a fraction, so it's going to be positive 2 over 1, and then our y-intercept is positive 3 at 0, 3. So on the y-axis, I'm going to plot a point at positive 3, and then I'm going to rise up 2 to the right 1, because we have a rise over run. And it's a positive slope, so it should be a positive line. I'm going to go ahead and plot as many points as I can following the same slope here. Okay. And then I'm going to go ahead and draw my line to connect all these points. Now, obviously this topic is parallel lines, and so you might know a little bit about parallel lines already, but not probably enough to justify why two lines are parallel. And just saying that they look parallel isn't really a mathematical reason. I want you to look at these lines and tell me, do you think these lines are ever going to cross each other? And the answer is no. Now you could say, well, because they're parallel. Well, what do you know about parallel lines? How can you claim that they're parallel? Well, I know that parallel lines or two lines are never going to cross each other. But how can I justify mathematically why they're never going to cross? Well, if you look at their slopes, right, they both have a rise of 2 and a run of 1. So they're rising and running at the same time. They have the same rate of change, the same slope, the same rate. If they have the same slope, they're rising and running the same amount. If you're running right next to somebody on a track and you guys are running at the same pace, is one of you going to cross the other one if you're running at the same place? No. You should be running at the same pace, which means you'll never cross each other unless someone changes their rate. Same thing with lines. If they have the same slope or the same rate of change, you're never going to cross each other because you're moving at the same rate constantly with each line. So our topic today is going to be about parallel lines, and just the general definition of parallel lines. These are lines that never intersect. Now when we get to Unit 5, that's going to be actually an important topic for us, when lines never intersect. And you can also say that they never cross as well. So they never cross and they never intersect each other. Okay? Now, what makes lines parallel with each other? Okay? Well, the important thing about this, we kind of just talked about it. What makes two lines parallel? Well, they must have the same slope. They must have the same slopes with each other. If they don't have the same slopes with each other, then they can't be parallel with each other because they would have different rate of changes. All right, so before we actually begin creating equations of parallel lines, we've got to first be able to determine whether two lines are parallel or not. Now, the next lesson is over perpendicular lines. Now, that's a completely different lesson, and so this lesson we're just focusing on, is it parallel or is it not parallel? And just because it's not parallel doesn't mean it's perpendicular, okay? So you can either say that it's parallel or it's not. You don't really know much else yet. Now, in order to determine if two lines are parallel, what do they need to have that it's exactly the same? Oops, my Notability just crashed. What do two lines need to have that are exactly the same in order for them to be parallel? They must have the same slope. So the easiest form for me to see parallel lines in is the form of slope intercept, y equals mx plus b. When it's in slope intercept form, it's very easy for me to identify the slope because it's always going to be right next to that x, but only if it's in slope intercept form. So I want to get it into y equals mx plus b. I always want to get the y by itself, and once the y is by itself, completely by itself, then I'll know what the slope is. So starting with number 1 with the first equation, y equals 3x plus 4, do I know the slope of this line? And in this case, I do. The slope of this line is going to be positive 3. Now, how do I already know the slope? Because the y is by itself, and it's in y equals mx plus b form. If it is in slope intercept form, I know the slope without having to do any work. So our slope here is going to be positive 3. Well, for the next equation, we have y equals 3x minus 7. I also already know the slope because it's in slope intercept form. Y equals mx plus b. Y is by itself. So my slope here is also 3. So are these slopes exactly the same? They are. So that means that these are going to be parallel. They are indeed parallel because they're exactly the same. If they have the exact same slope, they're going to be parallel to each other, which means if I were to graph both of these equations on a graph, they would never intersect each other. Moving on to number 2, we have 7x plus 3y equals 9 and y equals 7/3 x plus 6. Now with this first equation, do we know the slope? We do not. The slope is not 7, okay? A lot of people will be like, oh, what's next to the x? It has to be the slope. However, this is not in slope intercept form. It's actually in standard form, and standard form does not give us the slope. So what you want to do is you want to get that y by itself so that you can get it into slope intercept form, y equals mx plus b. So I'm going to go ahead and go down here, copy the equation down, and we're going to solve for y. We're going to get y by itself. So our first step here we're going to do is to subtract 7x from both sides. Remember, our goal is to get y by itself. So we have 3y equals 9 minus 7x. And we have a little bit of practice with this in Unit 3, so we should be able, or a little bit comfortable with getting y by itself. Our next step here is going to be to divide by 3 to every term, to everything. So I'm going to take 3 and I'm going to divide it out to everything. So I have y, because 3 divided by 3 is 1 and they cancel. 9 divided by 3 is 3. Negative 7 divided by 3 is going to be negative 7/3 x. Now, why did I do this? Right? Why did I do this? Well, I want the y by itself, but why do I want the y by itself? Because I'm trying to identify the slope of this equation. So what is the slope of this equation? Well, the y is by itself, so it's in slope-intercept form. So our slope here is going to be negative 7/3. So go ahead and write that next to this equation. Our slope here is negative 7/3. Okay, well, moving on to the second equation, we have y equals 7/3 x plus 6. Now, do I know the slope of this equation without doing any work? Yes, I do, because it's in slope-intercept form. Y is by itself, it's in y equals mx plus b. So the slope here is going to be 7/3. So the question is, are these parallel to each other? They are not. They have to be exactly the same. So because one's negative and one's positive, it makes them not exactly the same. So these are not going to be parallel. Okay. Also, vocabulary and reading are super important in Unit 4. It is super, super important because their problems look exactly the same except one word will change. So it's really important that you're reading and understanding what each word means. Now, if you're kind of stuck on why parallel or what parallel really means, the way I learned it was that the word parallel, the way it's spelled, you have two L's right here. And these two lines and the L's never cross each other. So those are parallel lines. So you want to think about, oh, I have two L's and they're parallel. And actually, in geometry, when you move on, the symbol for parallel is actually two little slash marks that look like this, and that indicates parallel. When you learn perpendicular the next day, then I'll go ahead and show you what the symbol for perpendicular would be. But in the word parallel, you have two L's, and those two L's are two lines that will never cross. So those are your parallel lines. So we know that when we graph it, we don't want them to cross each other. Okay, so moving on to number 3, 3y minus x equals 6, and 3y equals x plus 5. Now, in the first equation, y is not by itself. This is not in y equals mx plus b form. And neither is the second equation. So what are we going to have to do? Well, we're going to have to split up our space because we're going to have to take both equations and convert them into slope-intercept form. So I'm going to take the first equation over here. I'm going to start with red, and I'm going to put it on the left. So we have 3y minus x equals 6. And then I'm going to take the second equation and put that one on the right. 3y equals x plus 5. Well, I'm going to work with the first equation first, the red one. Now, first step here is we want to get y by itself. I want to get y by itself so I can see the slope. The reason why I want to look at the slopes is because that's how I can tell if two lines are going to be parallel or not. You want to look at the slopes. The slopes are going to tell you whether or not they're parallel. So our first step here is I got to get y by itself, so the first step is going to be to add x to both sides. Remember, you're always going to add and subtract before you multiply and divide. 3y equals 6 plus x. Okay? Now, our y is almost by itself, but not quite, right? So we want to get that y by itself, but there's a 3 attached to it, so we're going to divide that by 3, and we're going to divide everything by 3. Okay, well, 3 divided by 3 is going to cancel and give us 1, so we have 1y, but we don't write the 1 there because that line looks weird, equals 6 divided by 3, which is going to be 2. Now, what number do we have next? Well, the number attached in front of the x is a 1. So really, you have 1 divided by 3, which is going to be positive 1/3 x. It's super, you need to be super careful that you recognize that there is a 1 in front of that x. Because if you forget that there's a 1 there, you're going to get your slope wrong. So what is the slope of this equation? Well, I know what the slope is because y is by itself, so it has to be in slope-intercept form. Well, our slope here is going to be positive 1/3. So that's our slope for this first equation. M equals 1/3. All right, moving on to the second equation. Now this equation almost has y by itself, except there's a 3 attached to it. So the only step that I really have to do here is to divide by 3 to everything. 3 divided by 3 is going to cancel. I get y. Now remember, in front of that x, there is a 1. So I'm going to have 1 divided by 3, which is 1/3 x. And then I have plus 5/3. So what is my slope of this equation? Well, the slope of this equation, again, y is by itself, so I know what the slope is. Slope is 1/3. So I have the slope of 1/3 for the second equation. So looking at our two slopes, are these lines parallel to each other? Yes. Remember, parallel lines have the same slope. So these would be parallel to each other. That's a really big box for the word parallel. Let me make that smaller. There we go. It's a little smaller, right? All right, moving on to the last equation. We have y equals 3 minus 6x and y equals 6x minus 3. Not last equation, last problem on the front page. All right, well, looking at the first equation, I already know what the slope is because y is by itself. Now, you want to be careful with this. Is the slope 3 or is it -6? The slope here would be -6. Now, how do I know that? Because the y is already by itself. It's in slope-intercept form. It's in y equals mx plus b. So I already know the slope without having to do any work. Same thing with the second equation. It's already in slope-intercept form. So I already know the slope without having to do any work. Slope here is going to be +6. Are these parallel lines? If I were to graph these, would these lines cross each other or be parallel? These are not going to be parallel. And the reason why it's not parallel is because they have to be exactly the same. So these two lines, if I were to graph, would actually cross each other. So these are not parallel. So hopefully that gives you a little bit of an idea of what parallel lines should look like when we're talking about equations. Basically, you want to get y by itself so you can determine whether they're parallel or not. You do not know the slope unless you have it in slope-intercept form. So don't state the slope before you actually look at your equation. Be like, do I actually know the slope here? All right, so now we're going to go into actually writing equations of parallel lines. So we're going to start with these. It is super important that you read and underline any important information they give you. So that's what I'm going to do, and I'm doing it to help you build better note-taking strategies and better test-taking strategies. I don't need to do this for myself, so anytime I'm underlining or highlighting, it's because it's something important. So we're asked to write an equation of the line that goes through -2, 3, and is parallel to y equals 3 minus x in slope-intercept form. Okay, so the first thing they're telling us is to write an equation. So I know at the very end of this, I have to have an equation written. That's what they want from me. Now, they want that equation to go through the point -2, 3. So they're telling us, hey, use this point, -2, 3. So I know that for a fact. I know I need to use the point -2, 3. Okay, so I have to use that point. Now we want to make a line that is parallel. I was like, what kind of line do they want us to make? They want us to make a line that is parallel. Now what do I know about parallel lines? They have the same slope. Okay, now I know this seems weird because we haven't learned any other lines that don't have the same slope, but the one that we do the next lesson, it's very important that you read and be like, do I want a parallel line? Do I want a perpendicular line? What kind of slope do I need? Those are important things to point out. So if they're wanting me to create a parallel line, I know that my slope has to be the same as the slope of the other line if I want to make it parallel. For example, if they're giving me an equation y equals 3x minus 5, they're like, hey, make a parallel line to this. Well, whatever that line is going to be, I have to have the same exact slope. I have to have at least a 3 here because in order for them to be parallel, they must have the same slope. Now, that's just an example. Okay, I want a same slope. Now, they're telling me I want it to make it parallel to this equation. Now, looking at this equation, what do I know? Well, do I know the slope of this equation? I do. Y is by itself, so I do know the slope here. So if y is by itself, the slope should be easily identifiable. The slope here is going to be -1. Now, why is it -1? Because remember, in slope-intercept form, in y equals mx plus b, your m or your slope is attached to the x. So your slope here is -1. Okay, so like, what are we actually being asked to do here? So let me go ahead and pop over to Desmos to kind of show you what we're doing. So they're telling us that they're giving us the point -2, 3. So I'm going to go ahead and plot that here on this graph. So that's the point -2, 3. Then they give us the equation y equals 3 minus x. All right, so we're given this blue line and the red point. They're saying, I want you, the person that's doing the work, I want you to create a line that goes through this red point right here that is parallel to the blue one. So they're saying, take this blue equation, remember these are both from the problem. Take this blue equation, so graph it, right? And then they're saying, create a new line that goes through this red dot that's parallel to the blue one. So in actuality, we're asked to draw a line that kind of looks like this, that it has to go through this red dot. So hopefully you can see my little cursor. You want that line to be parallel to the blue one. Okay, well, I know also at the very end that my equation should be in slope-intercept form. So when I finish this equation, it needs to be in y equals mx plus b form. It has to end in that form because that's what they asked from me. All right, so let's go ahead and start. What do we know? We know it has to go through the point -2, 3. So when I graphed it on Desmos, it was that red point. And then they're telling me they want to create a parallel line to this equation. That's the blue line that I graphed. Now, this equation has a slope of -1. Okay, if this equation has a slope of -1 and I'm asked to create a parallel line, would I use the same slope? The answer is yes. In order to create a parallel line, you have to use the same slope. So if the slope of this equation is -1, then the equation for my new one has to also be -1 in order for it to be parallel. So we have a slope and we have a point. We have a slope and a point. So if we have a slope and a point, or a point and a slope, we have to start in what form? We have to start in point-slope form. So you're always going to start in point-slope form. So that's y minus y1 equals m times x minus x1. We're going to start in this form. This is why we learned Unit 3 before we learned Unit 4. We have to know how to write a point-slope form equation. So I'm going to go ahead and plug in the information I know. So I have y, remember opposite signs, -3 equals our slope. Now remember, we want to use the same slope because we're asked to create a parallel line. Parallel lines have the same slope, so I have to use the same slope. Okay, and then we have parentheses x, and then our x1 here is -2, but when I plug it in, it's going to have an opposite sign of +2. So I'm using my point, and then I use the slope. Now question, is this the form that they want my final answer in? Do they want point-slope form? They do not. What form do they want me to end in? They want me to end in slope-intercept form, in y equals mx plus b. So I have to convert this to slope-intercept. My first step would be to, and I gotta use a different color, to distribute. So we're gonna distribute first. We have y minus 3 equals -1 times x is gonna be -1x, but I'm just gonna put -x. You can put a 1 there if you want to, if it makes you feel better, or if it helps you, that's perfectly fine. And then -1 times 2 is gonna give me -2. My next step here is I'm going to get y by itself by adding 3 to both sides. Okay? That 3 is so small. Okay. And then we have y equals, those 3's cancel, and so we have -x, -2 plus 3 is going to give us +1. Is this in slope-intercept form? Yes. So then this would be my final equation. Remember, they asked us to write an equation in slope-intercept form, and that's exactly what we did. Now, question. Is this equation the same as this equation up here? No, and they shouldn't be because you're creating a brand new line. So let's go ahead and see if this line actually matches up with what we needed. So that's the equation we have, y equals negative x plus 1. So remember, in the problem, we were given an equation. We were asked to create a parallel line to this red dot. So let's see if it actually worked. Y equals negative x plus, is it plus 1? I think it was plus 1. Yeah, it was. Okay. And if you look, do you see how that line that we just made, this green one is the equation that we just made. It goes through the red dot, and it's parallel to the blue line that they asked us to make it parallel to. And if you look and you zoom out forever and ever, these lines are never going to touch because they have the same slope. So that's essentially what we're doing here. I'm just showing you a picture so that you can kind of visualize what's happening. All right, so moving on to the next problem. Write an equation of the line that goes through negative 1, 1 and is parallel to negative 3x plus y equals 5 in slope-intercept form. All right, let's go ahead and identify some of the important information. Well, we know that the new line, the new equation, has to go through the point negative 1, 1. It has to go through that point, all right? And then it says we want it to be parallel. We want to create a new equation, and we want that equation to be what kind of line? A parallel line. Remember, parallel lines have the same slope. So I know that the slope of my new equation has to be the same slope as the old equation that they're giving me. They're wanting it parallel to this equation in slope-intercept form. Remember, that means we want to end this with y equals mx plus b. Always pay attention to what exactly they want. It is super easy to miss stuff in Unit 4 because we do not read very carefully. Make sure you're reading every word very carefully and doing exactly what they've asked of you and going back to make sure that you've done exactly what they want. All right, now, before I can actually create a parallel line, I need the same slope. Now, do I know the slope of this equation? I do not yet because y is not by itself. I have to get y by itself in order to identify the slope. So the first thing I'm going to do is add 3x to both sides to get the y by itself. So the negative 3x plus 3x cancels, and I have positive y equals 5 plus 3x. The y is by itself now. So what is the slope? The slope here is going to be positive 3. Now, am I going to use this slope? Am I going to use the same slope for my new equation? Yes. Why do I want to use the same slope? Because they've asked me to create a parallel line, and I know that parallel lines have the same slope. So I have a slope, and I have my point of negative 1, positive 1. I have a slope and a point, so I'm going to start in point-slope form. So I have y minus 1 equals 3x plus 1. Okay, remember, we're plugging in our point. Make sure when you plug in your point, you plug it into the right y and x values, and you plug in your slope correctly. And remember, when you plug in your point, your signs are going to change. All right, so the next step here is to get this to slope-intercept form because that's the final form that they want the answer in, not point-slope. So the first thing I'm going to do is distribute. So we have y minus 1. Oh, gosh. Okay, we have y minus 1 equals 3 times x, which is 3x. 3 times 1 which is positive 3. Then our final step here is to get y by itself by adding 1 to both sides. Oops. So we have y equals 3x. 3 plus 1 is 4. Now this is in slope-intercept form. So that means my equation is done. So what did I basically do? They gave me an equation, and they said make a parallel line to this equation, which I did. Okay? And it has to go through the point negative 1. Negative 1, 1, which it does go through that point. So we've done everything we've been asked to do. Okay, now again, should your equation from the first part at the very beginning match the very last equation that you have? No, they should be different because you're making a parallel line. If they're the same equation, then they're not parallel. They actually are on top of each other and cross infinitely. So you want your parallel lines to never touch. So your equation should never match the one that they give you. They're just giving you the other equation just so that they can show you the slope that you want to use. All right. The next one is number 3. Write an equation of the line that goes through 4, negative 5 and is parallel to y equals 6 minus 1/2 x in slope-intercept form. Okay, so what do we want to do here, right? We want to make a line, write an equation that goes through the point 4, negative 5, okay, and is parallel. So we want to create a parallel line here. What do we know about parallel lines? Parallel lines have the same slope. So that means that when I create my new equation, it's going to have the same slope as the old equation. Now we want that parallel to this equation down here. okay? And we want it in slope-intercept form in the very end. So we want it to be in y equals mx plus b at the very end, okay? Now we want it in slope-intercept form. Now, I encourage you to try this problem on your own if you're able to. If not, that's fine. But I want you to try because you always want to try and see if you can do it on your own. All right, so what are we going to do here? Well, we want to see the slope of this line. Do we know the slope of this line? Yes, and I know the slope of this line without doing any work because it's already in slope-intercept form. Y is already by itself, so my slope here is going to be negative 1 over 2. Now, would I use this slope for my new equation? Yes. Now, why do I want to use the same slope? Well, they're asking me to create a parallel line, and what do I know about parallel lines? They have the same slope. So I know that it has to be parallel to this guy. And if it needs to be parallel, it has to have the same slope as it. So I'm going to use the negative 1/2, and then I'm going to use the point that they give me, which is 4, -5. I have a point, and I have a slope, so I'm going to start in point slope form. So we have y plus 5, because the y gets plugged in first, equals -1/2 x minus 4. Okay? So we're going to move on. Now we want this in slope-intercept form, so we are not done. We're going to go ahead and distribute in. So we have y plus 5 stays the same, equals -1/2 times x is -1/2 x. -1/2 times -4 is positive 2. And then we want to go ahead and get the 5 by, or not the 5, the y by itself, and we're going to move the 5 over by subtracting it and doing the opposite. So we have y equals -1/2 x minus 3. And this is in slope-intercept form, so this is our final equation. So I'm going to go ahead and check this with Desmos because I do not have a key, and I want to make sure I'm doing this correctly because it would suck if I did it wrong in a video. 4, -5 is the point that they wanted us to use. And we have y equals 6 minus 1/2 x. Whoops. Okay, so that's the equation. There's that purple point. And then we came up with the equation y equals -1/2 x minus 3. Perfect. All right, so yeah, it goes to that purple point, and then it is parallel to that black line that they gave us originally. So that is the equation. All right, now the next 4 problems are going to be very, very simple to do, but they're also very easy to miss because sometimes they're not very clear because the instructions, and it doesn't look like one of the equations that we just did. It doesn't look like the problems we just did. So let's go ahead and go through these. Write an equation parallel to the x-axis and goes through 3, -1. Now what's different about this problem? Do they give us an equation like the other problems have? They didn't, right? Like in the last 3 problems, they gave us an equation, here's another equation, and here's another equation. But in this one, they didn't give us an equation, right? If it's not a normal problem, I want you to draw a graph. If it is not normal, I want you to draw a graph. Now the reason why is because they're actually very simple to do, but it can be hard to visualize in your head. So what we're going to do is we're going to draw a graph here. Now we're going to draw it the same way I do. Don't make it overly complicated, okay? And you're going to make your little x and y axis right here. Okay, and I typically try to make your numbers pretty small, so, oops. So I'm going to go ahead and just draw 5 tick marks. So you'll never need more than about 5 tick marks. Oops, didn't make my line long enough. There we go. 1, 2, 3, 4, 5. All right, so I have a coordinate grid here, and I'm going to copy this. I can paste it on the other ones. So now why am I drawing a graph? Because this is not a normal problem. If it's not a normal problem, draw a graph. It really, really helps if you just draw a graph. It helps you visualize and makes it go a lot quicker. Now you're asked to write an equation. So you know at the very end of this, you have to have an equation written, and that is your answer. This picture that we're going to have here is not the answer. So make sure you actually write the equation. So I'm actually going to underline write an equation just so we remember, right? We're going to write an equation by the very end. Okay. So why am I drawing a picture again? Why am I drawing a graph? Because it's not a normal problem. They did not give us an equation. If they don't give us an equation to use, we have to go through different methods, right? Like here, we didn't have to draw a graph because they gave us an equation. We know exactly what to do. They didn't here. Okay, now what do we know here? We know that it has to go through the point 3, -1. So let's go ahead and plot that point. Positive 3, -1 is going to be located right here. The point 3, -1 is located right there. We know that the new equation has to be parallel to what? parallel to the x-axis. So I'm going to go ahead and highlight the x-axis here. The x-axis is located right here. That's my x-axis. So they're telling me that I need to write an equation that is parallel to the x-axis, and it goes to the point 3, -1. Okay, well, it has to go through this green point here. My new line, oops, I did not mean to do that. Oh no. Okay, 1 second. I just erased my highlighting. X-axis. Here's my highlight. Oops. Okay, so I want the new line to go through the green point and be parallel to the x-axis. So when I draw a line through this green dot, do I want the line to go like this? Or do I want the line to go like this? Well, I want it parallel to the x-axis, which means I do not want it to cross the x-axis. So the line is going to go horizontally. It's going to go through that point, and it's not going to cross the x-axis because we want it parallel to the x-axis. So our line is going to run that way. Okay, again, how did I get that? We want it parallel to the x-axis. We do not want it to cross, and so that's why the green line is going side to side, left to right, because I don't want it to cross the x-axis. If I create a vertical line, then it's going to cut through the x-axis and it is not parallel. All right, now here's to write the equation. Okay, these equations are super easy. You just have to look at the graph that you just drew to help you. Okay, what axis does this green line cross? The axis that the green line crosses is the y-axis, so it's going to start with y equals. What number does the line cross at? It crosses at the number -1. So our equation is y equals -1. Now, if you're able to do this in your head, you can definitely do it in your head. But if you can't, then drawing a picture is always a safe bet. Now, why do I draw a picture? Because it's not a normal problem. If it's not a normal equation or it's not a normal problem, draw a picture to help guide you. If it's a normal equation like the last 3 that we've been doing, then you do just straight algebra, just straight math. You don't really need a ton of algebra math here. We just need to have some visuals to help guide us. All right, so number 2 is going to go by a lot quicker because we've already done one. Write an equation, so we know we need to write an equation at the very end. We have to have an equation. The picture is not the answer. Write an equation that is parallel to the x-axis. So I'm going to go ahead and highlight my x-axis. I know that my new equation has to be parallel to this one. Okay, it has to be parallel. Okay, now what point does our new line have to go through? Well, it has to go through the point -2, 4. So I'm going to go ahead and graph that. -2, 4 is going to be located right here. Oops, right here. Okay, so that's the point -2, 4. Now I want this to be parallel to the x-axis. So I do not want it to cross the x-axis. And so since the x-axis runs left to right and I want it parallel, then this line is going to go left to right. Whoops, it's going to go left. My pen broken? What's going on? I think my notability is stuck. Yep, it's crashing again. Sorry about that. All right. Now it's writing. Okay, so because the x-axis runs left to right and I want to make a parallel line, then this line is also going to run left to right because I don't want it to cross. I want it to be parallel. So what would the equation of this line be? Well, looking at my green line, it crosses through the y-axis, so it's going to start with y equals, and it crosses through the number 4. So we have the equation y equals 4. Now we've seen these before in Unit 3. These kinds of lines have a 0 slope and they are horizontal. So these kinds of lines are horizontal lines. Okay, moving on to number 3. Write an equation that is parallel to the y-axis and goes to the point 5, -2. All right, so very similar to the last few, write an equation. So I know at the very end I have to have an equation. I want it to be parallel, which means I do not want it to cross to the y-axis. So I'm going to highlight the y-axis to help guide me here. I don't want it to cross that that yellow highlighted section. And then I want it to go through the point 5, -2. So I'm going to go ahead and plot 5, -2 for us, which is going to be right here. Now I want the equation, the line that goes through that green dot, to be parallel to the y-axis. So if I want it parallel, I don't want it to cross. So the question is, would I make the line go side to side, left to right, or would I make it go straight up and down? The answer is straight up and down. And the reason why we want it straight up and down is because we don't want it to cross the y-axis. We want it to be parallel. So how do we write the equation for this? Well, what axis does the green line cross? It crosses the x-axis, so it's going to start with x equals. And it crosses the number 5 on the x-axis, so it's going to be x equals 5. Now we did see these types of lines in Unit 3, and these types of lines have an undefined slope. The equation of the line is x equals 5. The slope is undefined, but the equation is x equals 5. All right, moving on to the last problem in this section is write an equation that is parallel to the y-axis and goes to the point negative 4, 3. We were asked to write an equation, so make sure that you're not just drawing the picture, that you actually write the equation. You want it parallel to the y-axis, so we're going to highlight the y-axis here. We want it parallel, so we do not want it to cross, right? So we want it to go through the point negative 4, 3. Negative 4, 3 is located right here. Now I want it parallel to the y-axis, and I want it to go through negative 4, 3. If I want it parallel, I do not want it to cross the y-axis. I want it to be running along it and never touching it. So, what axis does this equation go through? What axis does this green line go through? It goes through the x-axis, which is why it's x equals, and it goes through the number negative 4. So our equation is x equals negative 4. Okay, so those last four were super easy as long as you have some guidance. Now, if you can do this in your head without drawing it, that's perfectly fine. But these questions can be super easy to miss. So if you want to just draw a picture for yourself to have that extra sense of security, you may do so. Now, again, these last three problems at the very beginning that we did, the very first three, we did not draw a graph because we were given an equation and it was normal, and we put it in point slope form because we have numbers and we have an equation, we have variables. But with the last four that we just did, there was no regular equation. We were just given a visual, so we want to draw a visual. If you're not given a normal problem, draw a graph. If it's a normal problem, do not draw a graph. Okay, write the equation of the line parallel to the graph shown and goes through negative 3, 1 in standard form. Okay, so we know that at the very end we have to write an equation, and here's the trick with this one. It has to be in standard form when you finish this. So when you finish this problem, it needs to be in the form ax plus by equals c. Now there's three rules with standard form. The first rule is that x and y are on the left. The second rule is a has to be positive. And the third rule is you cannot have any fractions in your final answer. So those are the three things that we're going to have to remember. Now we know that we have to write an equation of a line, and the kind of line that we want to create is a parallel one. And what do we know about parallel lines? They have to have the same slope. Okay, they have to have the same slope. Well, we want the same slope to the graph shown, and we want it to go through the point negative 3, 1. So I know that I have to use the point negative 3, 1, negative 3, 1. So I know I have to use that, so I'll go ahead and mark that there. Now, I gotta find the slope of this line, because it says I have to use the same slope because it's parallel, so I gotta find the slope. So I see that there's 2 points here. I'm gonna start at this bottom point here, and we're gonna find the slope by doing rise over run. Okay, so we're going to rise to get to the next point. That's going to be 1, 2, 3. Now, because we went up, that's going to be positive 3. Then we're going to do our run, which is going to be 1, 2, 3, 4 to the left. That was 4 to the left, so it should be negative 4. So our slope here is negative 3 over 4. Now, question, would I use the same slope when creating my brand new equation? Yes. Why would I use the same slope? Well, because they wanted me to create a parallel line. And I know that parallel lines have to have the same slope. So if I want the new line to be parallel to this one, they have to have the same exact slope. So I'm going to use this slope, and then I'm going to use this point. So here we go. We have a slope and we have a point. So the first form we're going to start in is point slope form. So we have y minus 1 equals negative 3/4 times x plus 3. Remember, when you plug in your point, your signs are going to change. Okay. Then the next step I have to do here is I have to slowly get it to standard, but I can't go to standard immediately. We always start in point slope form, and then we're going to go to slope intercept, y equals mx plus b. So I'm going to first distribute. So we have y minus 1 equals negative 3 over 4 x, because negative 3/4 times x is negative 3/4 x. Negative 3/4 times positive 3 is going to be negative 9/4. Okay, so we have negative 9/4 here. Now our final, not our final step, but we're going to have to get y by itself here. So the next thing I'm going to do is I'm going to add 1 to both sides. So I have y equals negative 3/4 x. And then negative 9/4 plus 1 is negative 5/4, I believe. I'm going to double check this. I don't want to make a mistake on accident. Negative 9/4 plus 1. Negative 5/4, right. Okay. So negative 5/4. Now, this is in slope-intercept form. Now, for the first 3 problems that we did, this is where we stopped because they wanted slope-intercept form. However, they want this in standard form. So I can't stop here. So my next step would be to move the x to the left side because x and y have to be on the left. So the next thing I'm going to do is I'm going to add 3/4 to both sides. Add 3/4 x, I'm sorry. Make sure the x goes with it. Okay, now those 3/4 are going to cancel. So I have positive 3/4 x. Now it's positive because I added. And is this y positive or negative? This y is positive, so you make sure you put a plus y here equals negative 5/4. Okay, now this is almost in standard form except there's something wrong with it. In standard form, you cannot have fractions or decimals. So how would I get rid of these fractions? Well, anytime we have to fix a standard form problem, we're going to have to multiply something to everything. We're going to multiply a number to all of these numbers so that we can get rid of our fractions. And you always want to look at your denominators and look for that least common multiple. Well, our least common multiple denominator here would be positive 4. Okay? Now, if a was negative, for example, if this was negative, then I would have to multiply by negative 4 to get rid of that negative a. So we're going to do 4 times 3/4 x, which is going to give us 3x. 4 times y, which is going to give us positive 4y. And then 4 times negative 5/4 is going to equal negative 5. So then this form is now in standard form. Our equation is now in standard form, and it's going to be parallel to that one over there. So that is how we do parallel lines. The key thing is that parallel lines have the exact same slope. So if you're trying to figure out if 2 lines are parallel, you want to make sure they have the same slope. You do not know the slope of an equation until y is by itself. And when you're given something that's not typical problem where there isn't an equation, you're going to have to draw a graph to guide you. But other than that, these are parallel lines, and if you have any questions,